far from the coast, in deep waters, where the wind is stronger and the challenges are greater. Floating offshore wind is unlocking new frontiers for renewable energy, bringing turbines where fixed bottom foundation can't go. But building a floating wind farm isn't just about moving turbines offshore. It's about designing robust floaters to survive harsh ocean conditions, innovating mooring systems, scaling manufacturing, finding new ways to monitor, inspect, and maintain structures far from shore, and ensuring this project respect marine ecosystems. In this episode of BlueTech Around the World, I talked to Magali Mouriès and Laurent Verdier from BW Ideol. We explore the technological breakthrough, the market momentum, and the future of floating wind. Because the wind is stronger offshore, and so are the opportunities. Tune in now on your favorite podcast platform. Welcome to BlueTech Around the World, the go-to reference for blue technologies and ocean innovation. Here, we spotlight the cutting-edge solution, visionary leaders, and transformative ideas shaping the future of oceans and the blue economy. Today, we are trying something new. For the first time, we have two guests joining us to explore both the technological and market aspects of a major innovation in offshore renewable energy, floating offshore wind. Floating wind represents a major leap forward in the global energy transition, unlocking the potential of renewable energy in deep water regions like the Mediterranean. But what does it take to develop and scale these technologies? What are the key technical and commercial challenges? And how is this industry positioning itself for future growth? This discussion comes at a particularly exciting time for floating wind. Recently, EDF Renewable and Maple Power won the latest offshore wind auction in France for a 250 megawatt floating wind farm in the Mediterranean called Golfe de Fos 1. This project will be located 25 kilometers off the coast and is expected to supply electricity to 450,000 residents. It marks another significant step toward France's goal of deploying 45 gigawatts of offshore wind power by 2050. And when it comes to floating offshore wind, who better to guide us through this conversation than BW Ideol? Since 2022, BW Ideol has been a key partner in the winning consortium, contributed its expertise in floating foundation, and collaborating on foundation studies for the site. As a pioneer in this field, BW Ideol is actively shaping the future of offshore wind technologies, making them the perfect guest to explore this topic with us today. So let's welcome Magali Mouriès and Laurent Verdier from BW Ideol. Magali Mouriès is the Deputy Chief Technology and Innovation Officer at BW Ideol. She oversees cutting-edge R&D projects focused on mooring systems, subsea inspection, and environmental impact for floating offshore wind. With over 20 years of experience, she has worked as a project engineers, R&D project managers, business developers, and even co-founding a marine technology startups. Her expertise spans marine environmental protection, advanced marine technologies, and strategic innovation for sustainable ocean use. Laurent Verdier is the commercial director at BW Ideol, leading a multinational team across Europe, Japan, and Singapore, with 20 years of experience in project development and execution for major energy players. He has played a key role in landmark offshore wind projects like Block Highland in the US, Mercury in Germany, and Provence Grand Large in France. Today, he spreads BW Ideol commercial development, focusing on co-development projects and EPCI ventures. So Magali, Laurent, welcome to BlueTech Around the World.
Thank you, Marie-Lou.
Thank you, Marie.
Thank you for being here with us today. So to start, let's set the scene. Offshore wind is growing rapidly with both fixed bottom and floating solution gaining momentum. So could you give us an overview of the current offshore wind market? Where do we stand today and what role does floating wind play in the overall picture?
Thank you, Mario, for this question. In fact, the offshore wind market today, we can say it's shows the fastest growing energy with more than 70 gigawatt in operation today. And there is even an ambition to have 500 gigawatt installed by 2040. It's a global market with ambitions that have been announced on all continents. First, you have technology which are constantly progressing with bigger wind turbine of 15 megawatts. They are going up to 20 megawatts and more, which contributes really to stabilize the price of the electricity and to lower the levelized cost of energy. And also you have a regulatory framework that is defining the maritime zones, that is organizing the auctions, that is developing the supply chain and the network in order to make sure that the planning is in control. So today, the offshore wind is really the best contributor to the energy transition. Floating wind offshore is more an emerging market, sizable, with the same growth dynamic. Today, the target is to have 7 gigawatt of floating wind projects in operation or in construction by 2030 and 30 gigawatt by 2035. This market can reach countries where the water depth is too important for monopiles or jackets, and when the maritime area for bottom fixed are already occupied by some projects. So typically the countries in UK, France, South Europe, Korea, Japan, Taiwan, our company BW Ideol is present.
Thank you, Laurent. So as we just from you, offshore wind and an impressive growth trajectory, and floating wind is emerging as a crucial solution to extend wind energy to deeper waters.
BlueTech Around the World.
So these shifts have opened up enormous potential, especially as you mentioned in regions like the Mediterranean, where fixed bottom installations are not feasible due to seabed condition. So now that we understand the broader market, let's dive deeper into the fundamental of floating offshore wind, because I think it's what will interest our listener. So many of our listeners may be familiar with the traditional offshore wind, but floating wind is still relatively a new concept. So can you explain how it differs from fixed bottom offshore wind, just to have a clear understanding of the difference between the two technologies?
Yes, in fact, floating and bottom fixed uses the same wind turbine to produce electricity. The energy of the wind is converted into electricity thanks to the generator of the wind turbine. And the only difference, in fact, is that for bottom fixed, the foundation of the wind turbine is directly anchored into the seabed. Whereas floating wind turbine is installed on the floater, itself connected and moored to the seabed thanks to mooring lines, generally 3, 4, 6 mooring lines.
Okay, thank you very much, Magali. That's a great explanation. So if I understand well, as the difference between the two doesn't it will not have a big impact on all the value chain, because the turbine will be the same, the substation will be the same. It's more like on the mooring and anchoring that will have some difference. So even if it's a shift for the industry, you don't disrupt all the value chain and all the stakeholders in the sector. So that's one point. Okay, so unlike fixed bottom wind farm, which are secured directly to the seabed, as we understand, floating wind turbines are anchored using Mouriès system, and these flexibilities allow projects to be deployed in much deep waters, unlocking new energy potential. So let's see now, why is it so important? How is it well suited for deep water region?
In fact, far offshore and consequently in deep offshore, wind are stronger and more constant, offering higher electricity production. Above 40-meter water depth, fixed bottom is less competitive than floating wind, and in Mediterranean Sea, water depths exceed easily and quickly 50-meter water depth. And for example, in Europe, 80% of offshore wind potential lies in a water depth above 60 meters.
So it's not only because of the seabed condition and the deep water, which is a big point, but it's also because the wind are strongest, and so the potential and the productivity is better. Okay, so economy and also the geography of the coast. So as you mentioned, the coastal region, including the Mediterranean and part of Asia, the US, have deep water close to shore, making floating wind a necessity rather than just an option. And so with this geographical advantage in mind, let's now talk about what make floating wind more attractive than fixed bottom solution. According to you, what are the key advantages of floating wind compared to fixed bottom system rather than just productivity? Is there something else?
In fact, the first point is that thanks to floating wind turbines are far away offshore, far from land, and it reduces their visual impact on the coastal landscape. A second point is that floating wind is easier to install than fixed bottom. And in the case of BW Ideol technology, the assembly of the hull structure is assembled on the quay. And then the floating wind turbine is towed offshore to the installation site where the farm is installed, is located. And consequently, it reduces the cost and risk of marine works that, as we know all, that are quite complex. Decommissioning also is easier than for bottom fixed, and there is also no component left on site after the decommissioning of floating wind farm. In fact, floating wind, we can say that it is more optimal, and it has a better acceptability by population, and there is also less interferences with coastal activities, other coastal activities on site.
That's really interesting because, as you mentioned, beyond just opening up new location, to also reduce the visual impact and the conflict with other marine activities, so the social acceptability of these activities. And you point out about the installation and the decommissioning, and so reducing the environmental impact and also reducing the cost for the project leader and the owner is also something I think should really interest the different stakeholder of this project.
BlueTech Around the World.
Now I think we are clear about the differences between the two and also the key advantages of floating wind. But despite these advantages, floating wind is still considered as a less mature technologies. So why it has been more challenging to scale up compared to fixed bottom system?
In fact, at the beginning, the developer needs to design new technology, completely new technology, except the wind turbine itself. And the challenges were that the floater has to support high load due to floater motion caused by wave and current and wind effect on the wind turbine. And to face these challenges, the floating wind industry has to tackle technological locks about design, but not only, there is a strong need for innovation, for example, on mooring, in matter of design, in matter of components, try to identify the right component. And why not innovative component to make it stronger? We need also to innovate to develop a robust floater able to support strong metocean conditions with sufficient lifetime to reach competitiveness and reduce cost of energy of such new technology. Innovation in operating floating wind turbine to maintain offshore fixed structure is already something complex. So when vessels and floater are moving independently, it complexifies operation and it requires to adapt methods of work. These challenges are now back to us, but there are new ones due to the development of bigger and bigger wind turbine. Today, wind turbines for floating wind are expected to be bigger, more than 20 megawatts. And this is gigantic size and other challenges to solve.
I can really picture this trying to install to the maintenance with everything moving around. So yeah, I really get it. And actually, when you bring a new innovation in the market, when you disrupt the techniques, the technologies that are already there, it always takes time, as you mentioned, finding new materials, new installation, new strategy, new concept. So it's what goes with innovation, but I can see that BW Ideol find the solution for that. Now let's turn to BW Ideol and the innovation that sets them apart in the industry. So Magali or Laurent, what makes BW Ideol's floating foundation technology stand out?
I would say a relatively long experience. In fact, when the first floating wind turbine are tested in 2010, BW Ideol technology is developed in 2011 with the first models test in basin in 2012. After many efforts in designing, engineering, and testing, our first scale 1 demonstrator named FlowGen is born in 2018. It was a premiere in France, installed in the Atlantic offshore Nantes. It's a concrete floater. And we installed a second demonstrator in Japan in 2018 too, which floater is made of steel. Both demonstrators are operating since 2018. And it gives Ideol an extensive experience of floating wind turbine operation and more than 7 years of feedback from this experience. And it's significant in this new market.
Yeah, I really understand that when you are really bringing something new to the market, having this long experience, it's really important to advance in a really high innovation context and market. One of the standout feature of your technology is the damping pool. So can you give us a little more detail about it?
It's a square ring, amazing, but it's a square ring made of concrete or made of steel, and there are compartments inside that allows both stabilize and floats the floater. The wind turbine is installed on the floater and fixed to the floater thanks to a transition piece. The particularity of the damping pool technology is that the pool inside is designed to ensure that the waves are in opposite phase that stabilize the floater. And it's like a barge, in fact, equipped with a wind turbine on its deck that produce electricity. And mooring lines are connected to the floater until the seabed to maintain the floating wind turbine in position.
Thank you. I like when you picture in a simple way for our listeners. So thank you very much. And that seems to be a game changer. Stability is one of the biggest concerns in floating wind, and the damping pool, I think, significantly improves the performance in royalties, as you were mentioning. And beyond just the foundation, I know that you are also working on different technologies in the sectors.
BlueTech Around the World.
What are, according to you, some of the most exciting innovation in these areas?
Wow, there are plenty. We can make a focus on mooring. Mooring forms an integral part of the floating wind turbine, but to make this technology competitive and floating wind competitive compared to the other source of energy, innovation is a key. For example, for the mooring, BW Ideol was the first to introduce synthetic cable in floating wind mooring, reducing steel components because synthetic cable have a longer lifetime than steel components. But the reliability of floating winds also lies in its operability, meaning being able to maintain the asset along its lifetime. Subsea inspection is a part of this maintenance operation. And the challenge for floating wind and subsea inspection, in fact, is the huge surface to be inspected in a floating wind farm. In fact, you have several floating wind in the same farm, and you have to imagine that there will be plenty of mooring line, a huge quantity and a huge length of mooring line that you have to inspect to be sure that their integrity is good and that you can continue to operate the floating wind. So, okay, we know how to manage subsea inspection because such methods are well known in the offshore industry, but the challenges are that there will be plenty of wind farm and a huge quantity of subsea asset to inspect.
Thank you very much for your view on the technologies that will have an impact on the sector. So as I understand, the mooring system that you were mentioning, that is really important, and also the underwater inspection. As we mentioned, these advancements are critical to ensuring the long-term durability and the efficiency of floating wind farm. And as they can be bigger and bigger with more space, the scalability of this underwater inspection, I think, is also something important. Another key aspect is materials. You were also mentioning it. With offshore environment being so harsh, the choice of materials can make a huge difference in longevity and performance. So what role do new materials such as composites or corrosion-resistant coatings play in improving the efficiency and the lifespan of floating wind structure?
We can integrate such a new material to gain in matter of lifetime. With some material, it is possible to have at equal capacity higher lifetime for the components itself. Sometimes it gives more robustness. Sometimes it's also a question of safety, because thanks to new material, you can have lighter components. So handling of such a component, it makes it easier to handle it, to lift it, etc. So, and it will support improving the safety of operators. But also there is a question of eco-design, in fact. In the development of our technology, we consider an eco-design approach. One of the objectives is to reduce the impact of innovative material components, to reduce the impact on natural resources, and also to reduce the carbon footprint of floating wind and an industry more widely, in fact. Thanks to such innovative material, we can have a positive impact on the environment compared to what is existing.
Great. We can say that technology is advancing rapidly to make floating wind more reliable and cost effective.
BlueTech Around the World.
You begin to talk a little about it. This situation come also with significant challenges. Now let's shift our focus to the key obstacle in deploying floating wind farms at scale. Now that we have covered the technology behind the floating wind, let's dive into some of the biggest technical and logistical challenges of deploying this project at scale. One of the key concerns, of course, is the structural integrity and maintenance, as you mentioned several times. These turbines are exposed to extreme weather conditions, including rogue waves. What kind of testing or simulations are conducted to ensure long-term durability? What are some of the biggest technical challenges in deploying floating wind offshore at scale?
Yeah, so of course, we have to manage the risk during the development of the project. So after studies are being performed and iteration loops being conducted in order to really master the behavior of the unit under different conditions, we want to check the behavior, and we are generally performing a basin test in order to ensure that the behavior is as per plan, as per the design. And this is taking place generally after 1 year of design in some specific laboratory, which are present in the Mediterranean region, but also all over the place in the world, close to the installation sites. After the basin test being we will finalize the design with a third party to make the certification of such design, which is very important, of course, to then enter into the financial closing of the project. Something which is of importance is the track record. Here, Magali was mentioning it. We have more than 6 years of operation with our floating wind unit in France and Japan. And this is bringing the demonstrations that is needed for the investors to make sure that these assets can be operated and maintained in a very safe way. So maybe I will just give you a bit of figures on what are the capability of our floating unit installed in France in Flogène, nearby Le Creusot. We have been operating in condition with a wind speed up to 122 kilometers per hour. We have been measuring all the transfer of our personnel during normal maintenance activity. And what we have seen is that the design of our floating unit is a breakwater effect. Transfer people with wave up to 2.3 meter height. And this accessibility is an important point because it has a direct impact on the availability of the floating unit and the operation cost. Basically, what we also try to do is to avoid as much as possible the access by people. This is why, for example, we don't have any active ballasting system which are operating together with the wind turbine. We have only a passive a ballasting system which do not require any maintenance. So we generally have a design which is really mindful of limiting the access of manpower, and we are developing also a lot of robotic digital solution to anticipate and to optimize this maintenance.
Really great, as you mentioned, with the different example, offshore environments can be guiding, so rigorous testing and predictive modeling play a significant role in ensuring the reliability of structures. But what I hear from what you just say is that you have to convince on the technical aspects, the robustness, the safety, but also the investors that the project is viable because you will reduce the maintenance cost and the operation cost because the design, for example, you were mentioning the ballast, so that will not require so much people at sea. So, which is a key point regarding offshore work. So, yeah, really interesting to see how you manage these different challenges back with all your experiences, the testing, the certification, and all this design to make sure that it fits with the market. And speaking of logistic, grid connection and energy transmission remain one of the biggest hurdles for offshore wind in general. So, Laurent, what are the biggest challenges here? More in the transmitting power from the floating wind farms to the grid. Are the floating substation right now okay?
Well, it will depend more on the distance the wind farm will be from the coast, because you can have a transmission line which is having the same length and characteristics and with bottom fixed projects for which we have an amazing track record. The major difference will be coming from the dynamic part of the cable, which needs to move. The floating foundation is moving, and depending the water depth, the current, the wave height, the meteocean data, generally the displacement, let's say, of the floating foundation, this dynamic part of the cable will need to have a certain configuration, and this is where you find a lot of developments from the cable manufacturer. Of course, for projects for which the distance is far from the coast and you will need to have a floating substation, there are other challenges which are coming with this floating substation and the cables connected to it. And then you have displacement also to consider between this floating substation and the floating units. You have to make the right let's say definition of what are the part of cables which are buried, which are fixed, which are not moving, which have to be protected, and the right part which is dynamic, which needs to be disconnected, reconnected. And there are a lot of innovation and optimization which are being performed today because this operation of disconnection and reconnection are being done in expensive phase of the project, which are the maintenance phase, where some tugs are mobilized to stabilize the floating unit, and you basically need to have a system which is quick and safe.
It's clear that overcoming these deployment challenges will require an industry-wide coordination and innovation. So I'm assuming with some research centers, maybe university or industry partners to really have this coordination between the energies, operators, the cable, but also the structure and the foundation. So yeah, I can see that there is a whole ecosystem to making sure that everything is secure and have the less interruption in the operation of the farm.
Magali, I think you are completely right that it will require a lot of time and brain in order to tackle these innovative parts, which are very specific to the floating aspect, in order to master especially the operation offshore. On the other side, what we are doing in our company is really to leverage what is existing from the other industry and what is working well. Because today, maybe one of the major logistic challenges is not so much what is happening at sea, but it's already what is happening before we are loading out and laying off the floaters. We must understand that in the market, typically the UK market, which is maybe the first one in Europe for the floating projects, where 19 gigawatt of projects were awarded. It means that one floater every 3 days will have to be delivered in the industry from 2030, which is, let's say, showing a challenge concerning the supply chain that needs to be addressed. So maybe the first challenge that we want to address for the industry is this mass production aspect. And our floater in this case is a pretty, I think a pretty good shape in order to be manufactured in concrete with a concrete slip forming system, which helps the mass production of the floater and can be manufactured and delivered as for some concrete caissons that you are generally using for port extension. So we are having the philosophy to use what is already existing in some industries since 20, 30 years and to adapt it to the floating market in order to have the same pace of delivery and to be in control of the risk, the logistic risk, and the quality of our substructure. So this is one aspect. Like before putting concrete floater in the water, we have to handle all this assembly part, and we believe that today this is one of the major challenges of the floating wind, is how to assemble so many floaters in an efficient way so that it satisfies the pace of deliveries that developers are expecting.
That's a really important point. And actually, I know that the major port, European ports, but also worldwide, are trying to take the opportunity of offshore wind also to develop and diversify their activities at sea. So not only industrial, but also being the place where all the offshore wind activities for the manufacturing, the assembly, and also launching for the operation offshore. So that's a really good point. I'm just curious, as you are present internationally on this specific topic. For example, if you want to develop, I don't know, in country X, do you first map the stakeholders in the industry saying, are they mature enough? Do I have everyone to do the assemblies, the manufacturing in the place where I want to deploy my technology? How do you work? What is your strategy when you want to open a new market if you don't know if the value chain and the industry is ready or mature for that?
I think one good indicator is to see if first there are some bottom fixed projects which are already happening. So actually, we are not in competition with the bottom fixed projects. We are more following them. Or maybe bringing solution when there are some limitation for the bottom fixed project, because in some places we're already reaching the maximum capacity installed because we have to go now to deeper water. But when we are arriving in this kind of environment, the policies are in place. The grid connection is already prepared for that. You have a part of the supply chain which is ready, at least on the wind turbine side, which is an important item. And on the floating foundations, then it depends on what is the technology you are proposing. But in the case of BW Ideol, we have been very sharp in selecting a technology which was very easy to manufacture. It's very compact, so somehow we can assemble in a dry dock, in any shipyards. This can be easily assembled in steel. And as I was mentioning before, we can set up this production line of concrete floater in a pretty easy way, just like it is done in many countries to deliver some port extension. So we are not inventing the wheel somehow. We are leveraging what is existing from the bottom fix. So this is typically for a market where bottom fix is already existing. Then in some countries, we see that floating wind is the only solution. And we have to make more efforts, of course, to explain what is required to develop the supply chain. And we have to evaluate, for example, if the expectation is to develop a lot of local content, or if the expectation is just to deliver the floater free along the side, ready to be installed offshore. And in this sense, floating also is a very nice industry, because actually you could imagine that a lot of things are coming free alongside. There is no activity to be performed onshore. There is no factory to be implemented. We just need a quayside to make the wind turbine integration, and then it is going back offshore for the installation.
Really interesting, really good strategy actually, to focus on the one where there is already the industry with complementary activities such as fixed bottom offshore wind, but also having already designed the technology and the innovation to be easily scalable because it's compact, so could be easily manufactured and assembled in other countries. And for the one where there is no offshore wind activities yet, of course, I understand that maybe in some countries there is some local content in the tenders delivering by the different regulatory state. But I can see that you already have all this strategy set up to conquer this new market. So
BlueTech Around the World.
So now let's talk about the environmental aspect. We know that one of the major concerns when introducing any new technologies into the ocean is, of course, the environmental footprint. So how do floating wind farms minimize their impact on marine ecosystem?
First of all, I would like to say that where FloatGen, our demonstrator, is installed on the SEMREF test site in the Atlantic, an historical monitoring has been carried out, and it demonstrated that there is no significant impact of floating wind on the marine ecosystems. This monitoring is still ongoing, and to do so, we continue such work in the frame of different R&D projects. The first one is Piafenco. The purpose of this project is to better understand the impact of floating wind on birds and bats population. We would like to better understand the interaction between a floating wind turbine and such species. And the purpose is to better understand the interaction and the potential impact to define how to minimize this possible impact. That's the first point. We also carry out additional environment monitoring in the frame of the Velela project. The Velela project is not only focused on environment, but also the development of innovative technologies of mooring, improvement of the floater efficiency and maintenance technologies. But we approach this development through an eco-design approach at two levels. First, we want to continue to understand the impact of our mooring and floater on the marine ecosystem in matter of underwater acoustic, in matter of biology. When we talk about the artificial reef effect of immersed structure at sea, we are talking about biocolonization. We are also studying the impact on benthic communities and pelagic species. So we are deploying sensors and experimental campaign to make samples and to study this ecosystem. But there is also a second point in this eco-design approach. We see by design, we would like to reduce our impact on the environment by using less CO2 emitting component, by replacing steel by other components that emit less CO2. We would like also to identify what would be the way to recycle and to minimize the impact of the end of life of floating wind farm and floating wind turbine. We have a global view of the impact of our technology and of this industry to minimize the impact in matter of climate change and CO2 emission, the impact of floating wind on natural resources by optimizing the component and material that are used in the manufacturing of floating wind turbine, but also thanks to a better understanding of interaction with nature and ecosystem to define by design some solution to reduce the impact on marine ecosystem.
Thank you, Magali. Listening to you, I can feel this holistic approach, and that's encouraging to hear. We often talk about renewable energy as a key solution to climate change, but we need to ensure these projects are built in harmony with nature's. It is just as important, and we can't protect what we don't know. And the fact that you are doing all this monitoring campaign, you were talking about the water quality, the water noise, the impact on the marine species. So being aware of the marine ecosystem, the marine life, and understanding the different impacts that could be positive, neutral, or negative. So that was the first point, really to understand the impact, to monitor, to measure, and of course, having a proactive approach. And I can see that you are doing it, mostly with the eco design, which is really important, choosing the right material, the one with the less impact on the environment. I was thinking of the decommissioning and how to integrate the whole life of the project into your environmental approach. So thank you very much, because it sounds like a lot of efforts is being made to balance renewable energy growth with environmental responsibility.
BlueTech Around the World.
So now let's move on to the business side of things. How does floating wind compete in the energy markets? Actually, floating wind, you mentioned, is not really competing with onshore renewable, but could be complementary. We talk about solar, onshore wind, or traditional offshore wind. So, Laurent, how does floating offshore wind compare in terms of costs and competitiveness? I mean, floating wind has historically been more expensive than fixed bottom. So, how fast are costs coming down, and when do you expect price parity, if it could happen sometimes?
Thank you for this question. I think we have to use the right metrics and to compare things, in the perspective of the time frame. So the right metrics that we are using is what we call the levelized cost of energy. So it is considering the cost of construction, and it is also considering the cost of operation. So it is a global picture that needs to be considered. But something that is important is, of course, the size of the asset. The biggest the wind farm is, less there is a volume effects on the capex side, and there is also some benefit on the opex side. And this is the first advantage of the floating wind, is that once you are not limited anymore by the water depth of your geography, and that you are considering that it's a floating solution you need to envisage, then the maritime space you can occupy is pretty wide, and then you can really start to make optimizations of this space to size the project in a way that it is fitting the most the optimum between the big size and the small size. So we believe that there will be some demonstrations that floating wind is competitive in comparison to smaller renewable assets, smaller bottom fixed projects, or smaller onshore wind project. And when we compare to solar, we will never be competitive, of course, but in some areas of the world, you don't have space to put more solar panel. So there is, if you want to be in part of the energy transition, you have to be considering this floating wind units. So then we have the second thing we need to understand is that there have been a learning curve on the bottom fix industry, which started way before, and it started very high, and now it is at around 50 euro per megawatt hour, which is pretty competitive. Whereas the latest award you were mentioning in the introduction, the commercial project Golden Lion was awarded around a bit more than 85. So there is still a gap, but this gap is not so big. And basically, this tariff was also corresponding to the latest tariff of some onshore wind farms in France. So it shows that the floating wind industry is competitive already in the overall renewable energy pool. But we need, of course, to define what is the right cost reduction roadmap for the floating wind. And there will be two aspects for that. First aspect is that we need to have a supply chain which is able to massively produce the floating solution. And if we want to respect also some local content, it has to be some smart and easy solution to manufacture. If it is not massively produced, it's going to be a project by project approach, which is always going to be expensive and limited in volume. And the second, for ensuring this cost reduction roadmap, is really to continue to addressing, let's say, the size of the wind turbine. So it's important that the floating wind units are able to tackle a bigger wind turbine, because this is an important aspect. Eventually, if the floating wind unit cannot stand a bigger wind turbine than 15 megawatts, there will not be floating wind industry. So if you take, for instance, a 2 megawatt unit, we are speaking about a 34 by 34 meter 10 megawatts, we are speaking about a 45 by 45. We have a design ready, which is 15 megawatt, 54 by 54. And we are also working on a design above 20 megawatt, which will be by 60. So we have a pretty good scalability effect, meaning that as the wind turbine is growing, we can still follow the trend. And this is very important that the technologies can follow the growth of the wind turbine size.
Thank you, Laurent. I think it was really clear and interesting to see the roadmap for cost reduction. So if I sum up for our listeners, there is a scalability for the manufacturing of the floater and also the scalability in order to follow the growing size of the turbine. So being ready and being able to follow the trend of this growing industry. So that's a really good point. And it's good to see growing confidence in the sectors, especially with the increasing commitment from policymakers and investors. And speaking of the markets, BW Ideol is one of the key players. So if you can enter really specifically in the market of the floating offshore wind, how do you differentiate from your competitor in this growing market? You already gave us some insight with the fact that you have a compact solution for the scalability of the floaters, but also that I mentioned in the different projects, you are ready to scale the size to adapt to the size of the turbine. So yeah, if you can just tell us more about your positioning and how you compare yourself regarding the different competitors in the market.
I think when being a leader brings the advantage that we have some experience to share, and with this experience, you are reinsuring the investor, you are reinsuring the insurer on what will happen, and this is important because we have to explain that we are totally in control of what will happen from a cost point of view, from a planning point of view during the construction, but also during the operation and maintenance phase. And we have to demonstrate that, yes, the access is good. As mentioned by Magali, we can decommission easily, we can tow back the assets. These are important things to demonstrate with a real prototype. And also, it's not only the demo project, but we are involved in this pilot project. So probably one first information, and it's not only us, but this is important that to have experience. And this is first how we differentiate. We can prove the point, and we have been successfully been closing some commercial projects like Eomade. We are also a developer that have been successfully awarded the Buchan project in Scotland. So this experience is serving developers, partners in the auction process. We are coming with a solution which can be massively produced. So this is bringing a competitive advantage. So rather than to have a project by project approach, we can come with a solution which basically is going to come out of a production line, a concrete production line to serve multiple projects. So this is helping to consider a volume effect. When volume is a problem for other technologies because they need to find multiple sourcing solution in order to gather all the elements in one place, and this place has to be big enough in order to make the final assembly of their floater. In our case, the volume effect is helping because everything is managed as a manufacturing facility out of a production line. Track record, mass production for competitiveness, these are the two key points. Quality of also listening to our partners, to our customer, to understand what is the right level of local content they want to adapt, understanding the permitting condition. You mentioned the point before, like being conscious of the environmental consideration and having a design which is eco-friendly and which is considering also this permitting constraint to keep this leadership position also in terms of bringing some sustainable product to the market.
Thank you very much for this internal view of the market and of the strong leader positioning of BW Ideol. And that's a strong positioning actually, because we saw the experience that is really important, and also that you manage different position and role in different projects, so that give you different angle on how to approach a specific project that I think is really important. Also, this proximity with the market on the regulatory level, on the social acceptance level, but also on the technological level is also really important, so that you are riding with the wave of the market, for example, for the size of the turbine. And the good point that you were mentioning regarding scalability, because it's what will help you scale and reduce the cost. So yeah, really interesting to see how BW Ideol is playing this key role in the floating wind space.
BlueTech Around the World.
Now I'm a little curious about what does the future hold for floating wind. We just mentioned that the market is evolving with larger turbines and bigger wind farms. So how do you anticipate and prepare for this growth? For example, you were mentioning that the floater are going bigger and bigger to adapt to the wind turbine. Does this imply a lot of R&D? Is Ideol technologies ready for the next generation of floating wind project?
Yes, you're right. We partially answered before that addressing the size of the wind turbine is the first important trend. In our case, it's not a challenge. We see it more as a positive effect because, generally speaking, yes, we have a floater which is a bit heavy, which is statistically stiff, which means that it's not going to move a lot. So when other concepts are really optimizing the floater in order to be perfectly to the size of the wind turbine and very passive to the wave, and any change in the wind turbine side is a challenge for the floater. In our case, we have a floater which is a barge with a damping pool, which is pretty accommodating any type of brand of wind turbine. So in a world where you not completely sure what will be the final wind turbine brand you will be selected by the developer on the project, it's very important to have a floater which is accommodating this and this is pretty versatile on this aspect. So yes, the wind turbine size was a trend, but today what we are trying really to focus on is the de-risking of the manufacturing of it. We are not trying to, let's say, make our floater more competitive by saving some tons of concrete or some tons of steel. We want to have a floater that is pretty adapted to the industry, the shipyard industry for the steel, or that is pretty adapted for the concrete floating production that we are implementing in UK. So we are really focusing on this aspect, and to do that, we need to work with strong partners, shipyards for the steel part, but a civil work company for the concrete part. And we need to work more on how to optimize the sequence of the work. So this is for the onshore. It's really now to work on the industrialization, but we are going to come with some very good news on the partners we are teaming up with for this aspect. And then on the offshore side of it, we want to make it as simple as possible. What we have been doing with Flogen and Biki, the 2 megawatt project, what we will be doing on the Helmet project, are going to be setting up the basis of the right sequence for installation and offshore works for the commercial projects. So these are the trend today, and we are probably not the only one addressing it, is really on the industrialization aspect now in order to move from the pilot projects to the larger commercial projects.
Thank you very much for your view on that. Another trend we are seeing is hybrid and multi-use solution. So can floating wind be combined with other ocean activities such as floating solars, wave energy, offshore hydrogen production, or even aquaculture? Is it something that you already have some project or a view on that?
Yes, one of the market we are addressing is power to platform. So it's basically a floating wind unit which is equipped with a battery system in order to provide some sustainable power to the platform and avoid some gas consumption or oil burning. So this is one thing that we are offering to the market, which is combining a battery system, and we can also extend that to an hydrogen module. When it comes to, let's say, compatibility with other technologies, then going on the wind farm side, so I was more on the wind unit with the battery system and the hydrogen skid, but on the wind farm side, there is enough space between units to accommodate with other industries. So this is not really today addressed by us. It is more the global developer who has to consider that and see how it brings advantage or inconvenience to the project. But we can imagine that there will be first offshore wind farm which will be installed. The bottom fix will probably show that it's possible to have some a wave or floating solar in between if it is possible according to meteorological condition. And the same should be possible for the floating wind farm. And when it comes to aquaculture, actually, yes, what we have been observing is that in the offshore wind projects, there is more fish than before. So this is good for the environment. But and this could be a good place to actually develop some aquaculture. So when fishing is limiting, this is the right place, the right moment to develop aquaculture. aquaculture.
Thank you very much, Laurent, to have this multi-use view on offshore wind. As we approach the end of this episode, I just have one question. If you look ahead 10 years, where do you see floating wind's role in global energy mix, and what's need to make that vision a reality?
It will be part of the global energy mix. As mentioned, it will be an extension of the bottom fixed offshore wind project, and this industry is growing and it's establishing. And what we need to do is to stabilize also the floating wind in the same pace, so it will play a major role. We can even imagine that, the nice part of having a floating unit is that it can move it from one place to the other. So it could be also a contributor to temporary electrification needs on one remote island, on one electrification platform. This may offer some flexibility in the application. We are conscious that more and more of the population is living nearby the coast, and we are also conscious that the wind turbines are getting bigger. So floating wind is going to be somehow the best way to have offshore energy, but not too much visible, because we can put this floating project further away. So where there will be some limits maybe with other energy, floating wind being far away, this will help to continue the development of this solution.
Oh, finally, do you have any advice for our listeners interested in working in renewable energy and blue technologies?
Leave the last words to Magali, that will speak to the young generation. And on my side, being more coming from the project execution world and being mindful that we want to produce projects which are working. My message is that I believe that we need to be still conscious that we are in the start of this industry, floating wind industry, and it is important to share experience among ourselves and to work as teams. So there are some pilot projects which are happening. They are facing difficulties. This is normal. This was part of the purpose of making some pilot project. It's important this information to be shared between the different players to lower insurance case, to basically have a better insurability of these projects and to make this industry successful. And to the policymaker, of course, if they are listening by chance, is to ensure that it's not a new domain. It's more the extension of a very stable and very well established now industry. And there are a lot of very good engineers who are motivated to make this industry happen in a very safe and sustainable way.
Thank you, Laurent, for these inspiring messages. So, Magali, what is your message for the next blue generation?
Yes, my message would be to the young generation, and I would like you to encourage to take an interest to floating wind technologies and more in general in marine renewable energies to help meet the challenges of the energy transition and also to reduce the impact of human activities on the environment.
Thank you, Magali. We know that the new generation really want to have jobs that make sense, that have a good impact. And so I think working in the marine renewable energy and specifically in the floating offshore wind will be a great way to do this. So thank you very much, both of you. Thank you, Magali. Thank you, Laurent. That's wrap up today's episode. A big thank you for sharing your insights on floating offshore wind. If you enjoy this episode, don't forget to subscribe, leave a review, and share it with your colleagues who might be interesting. And until next time, stay curious and keep innovating with BlueTech around the world. Thank you.
BlueTech around the world.